Hello? Okay, good. Good afternoon, everyone. Welcome to the last session in this afternoon session. And I guess you guys have a few more talks to go before the happy hour. I'm Praveen Yalagandula from Avi Networks. And here I have my colleague, Gaurav Rastogi from Avi Networks too, and Nate Bechtold from EBSCO. Today, we are going to talk about continuous delivery for cloud applications, and we'll go through Canary, blue-green deployments, and how do you do them, and so on. So what's continuous delivery? And here we have a couple of quotes from the few well-known personalities who do very well evangelize the continuous integration, continuous delivery kind of things. So Martin Fowler says continuous delivery is a software development discipline, which is where the software can be released at any time. And according to Jez, it's about basically making deployments predictable routine affairs that can be performed on at any point on demand. It's about automation and integration of all stages of your software lifecycle. So everywhere, all the way from building, testing, all the way to your release and promoting your new version. In contrast, in old school, traditional software development and delivery, you have siloed ways of doing this work. Like you have developers doing development, build, testing in there for their components, and then release managers doing the integration test and doing a release candidates. And then you have the operators doing the deployments where they upgrade, validate, and may have to roll back. And then the bugs have to be fixed by the developers again, and so on. In this cycle, as you can see, this is a very long cycle. And from the time a feature is implemented to the time when it is delivered, it could be pretty long. In contrast, continuous delivery as a process is about doing all this very fast in a fast cycle, so that from the time you have the feature developed to the time it's deployed in your production, it's very short. But to be able to do all these steps, you need to have very short time for doing all these steps. So that means the automation is a very key component for every step of this process, for this life cycle. And also, you need to have the culture and the system in place where you should be able to do like these deployments with zero downtime. So typically, if you have these deployments that you want to do in zero downtime, you need to have some process in place how you can do these deployments. So that's where blue-green and Canary deployments come into picture. Blue-green deployment is where you basically have your current version of the software running in your system, and then you create an identical version of it, which is where you will have this new version that you are going to put into place. In contrast to old ways where you upgrade, where you have to take a time off from your main time and do it in the middle of the night, in case of blue-green deployment, you have your old version running at the same time, bring up your new version, which is green version, and switch all your new sessions from blue to green. And if it succeeds and everything is going good, you can then decommission your blue, and you can start throwing away and start preparing it for the new version. If the validation fails, then you can switch back to your blue because it's still there, and then you can use green for postmortem if something goes wrong. Now, as you can see, like in this case, you want to have like the graceful switchover of all your new requests and new sessions coming in, and that's where you need to have a very good model of your software where you can do this kind of switch over from one version to another version, and you need to have your deployments with some load balancer or some way to get your requests nicely migrated from one version to another version. Now, as you've seen in case of blue-green, you are basically spending resources on two ideal sets, same looking sets of deployments, basically 2x resources. In contrast, Canary is a bit more advanced technique, I would say, on top of blue-green, because here, instead of creating an exact replica, you basically only move a fraction of your traffic from your old version, version 1, which was your last good one, to version 2. So you start sending few of your sessions there. And if in case the validation fails, you start to monitor them, and if the validation fails, you can always switch back those sessions back to your version 1. And you can increase the load as the validations pass and keep monitoring and increase the loads as the time goes by. The cool thing about this is that if you have like nice elastic applications, then you don't need the 2x resources as you would need in the previous one, right? Like here, you can slowly, as the traffic increases, the auto scaling of if its application is auto scaled, then it will automatically, you start to deploy more of version 2 instances and slowly ramp down the version 1 instances. And this is the great thing about the Canary deployment.
So once you have the Canary deployment and you have thought about it, the important step is how do you take decisions to promote a version or do the qualification for a version under test. And there are 3 important aspects to it. So first one I would say is what is the pass-fail criteria? You have to think through it. And this thing works if you can quantify it, because just saying it is good or bad is not enough. You have to really be able to objectively see that, yes, it has met the criteria or not. And the best ways to do it is look at the performance metrics, error metrics, and resource metrics. Some of the well-known metrics which is used in practice, and you would see examples of it later in the presentation, are response time, open connections, errors, look at the quality of transactions going on. And so essentially be able to set up the criteria as if the response time is good enough and there are no errors and the resources are more or less what you expect from a previous version, then let the new version of the software get deployed further. Another important aspect is evaluation duration, like how soon, how long do you want to run a given software in a test mode. Some applications need only a couple of minutes, some need hours, some may need days, so that's a thought to be consider. And what is the ramp up of the traffic? Like, do you start with 1%, 5%, 10% increments? That's something to also think about. A lot of times it may not, just the goal may not be full deployment of the new version. The goal could be just to say new version gets 25% of the traffic at most, and then you want to maybe look at it, let it have a soak time, and then move it to the 100%. So these are the traffic engineering consideration that you would like to configure in your system and think about it. And the last thing is Audit Trail. And Audit Trail is very important because for an ops perspective, at any time there is change in the traffic, there should be a record of it, how much traffic was changed, and then what was the evaluation results at every round. If anything failed, then what exactly failed, so that it can be postmortem. And finally, what was the outcome of the version that was being Canary deployed. With that, I'm just kind of summarize. The goal of the continuous delivery is to have a predictable, reliable, fast, and better quality software. And some of the other benefits you get out of this is you have much better organization. You have a very efficient, automated, and very well-defined process to roll out software. And this also empowers software developers and the teams to do releases much more frequently and not have to wait for those traditional models where release happens only once in a year. The businesses love it in terms of sales team, PM team, and customers, because they can get releases much quicker, and the bug fixes can be rolled out very quickly as well. It's very good for operations. No one in operation wants surprises on the Thanksgiving Day or Christmas Day or shopping day. So this works very well for operations. There's better quality of software coming out, pretty much no downtime, and much lower risks in deployment. And one other aspect is maybe a little bit counterintuitive is about security. Having continuous delivery makes the whole software development a lot more secure. There is a quicker way to deal with zero-day situations and roll out patches. And at the same time, because the whole infrastructure is quite ephemeral, you don't have these very old servers which are not patched and sitting around, and that can be compromised. So with with that, I will hand it over to Nate, who's going to walk you through the case study of continuous delivery and really share his insights into lessons learned. Thank you.
Hello, everyone. I'm Nate Bechtold. I'm a platform architect at EBSCO. Just a quick overview. EBSCO is just a kind of a private database search company. Libraries are our most common customers. We do things like journals, ebooks. Basically, we allow people to search databases that are private, more curated, things that universities are more interested in, things you wouldn't find on Google. In terms of scale, we process around 670 million back-end searches a day. So we just completed probably around a year-long effort to really take a look at our delivery process and modernize it for some of our legacy large monolithic applications where they had really high-risk deployments. These were deployments where we had a lot of features we wanted to get out to customers, a lot of change, a lot of things we wanted to do. But our release process, we could practically only get it out about 2 to 3 times a year for some of the larger products. This really resulted in these really high-risk releases because when you have these really expensive, large manual releases, the natural incentive to start batching changes together because releases are expensive and hard to do. And that increases the risk by a lot. Instead of having one small change, you've now got 50 changes all going out at once. And when something breaks, you don't know what exactly it broke. So our deployments were risky. It was, they were really large effort, took a long time to roll out. And conversely, if there was a mistake made, it took a long time to roll back. So there was a lot of upfront tests, a lot of upfront effort that had to go into this. We had inconsistent environments, so you have your production environments get the most love in your organization, and your development environments and everything before that tends to have different processes around it or different levels of attention. Many times this leads to firefighting issues that may not have been even a problem in a production environment. And also leading to issues that would be a problem in production, making it way further down the SDLC than they should. We had unstable development environments, so a lot of them lacked high availability. They deviate in consistency from your live environment, so you get issues that happen in development, again, that wouldn't actually be problems. They have inconsistent patching and a lot of time often wasted fighting environment issues in lower order environments. Additionally, when we went to go automate things, we had a lack of reusable patterns. So things were built over time, and people would do things in slightly different ways for different services, which made it very difficult to kind of have a holistic automated solution at that point in time. It created this inconsistent operational view, so you'd have runbooks that would deviate just in little ways for every single service, and often not in meaningful ways. And we had to solve this at a kind of a non-trivial scale. So we were talking about around 300 developed services, around 8,000 different systems. We had to support both Windows and Linux. And really the things that we were targeting, which since we wanted to deliver value to our customers quickly, we were targeting our mission critical, really high volume systems. So there wasn't much room for failure here. So what we did, we coined this effort the Automation Factory. So when we kicked this off, we said we kind of tried to figure out what we were going to try to do and accomplish in the framework we were going to build. We came up with the name Automation Factory, and the idea is it builds and constructs environments and deployment pipelines with 100% automation, so with no manual actions allowed within the resources that it maintains. Now that 100% automation is a really important number because there's a very big difference in capabilities between 99% and 100% automation. If you put one manual step that has to happen in that pipeline or in that system that has to be provisioned, you're cut off from a lot of value. Things like auto-scaling or dynamic provisioning, you just can't leverage it because of that 1%. So we said no manual actions were allowed in this process. Everything has to be automated no matter what. All the environments along the way are built exactly like production with all of the supporting tooling, load balancers, everything completely provisioned and managed by the pipeline. Only scale is allowed to differ, so if we've got 200 servers in live, we might have 2 in the lower order environment, but there needs to be at least 2. There needs to be a load balancer, needs to be monitoring everything just like the live environment. It relies on an existing stable environment for anything that doesn't meet the 100% automation requirement, so we We weren't overly optimistic that we'd be able to accomplish everything at once, so we kind of put a walled garden. We said, inside this area, everything's automated, and here's everything that isn't, and here's the way you point to it. But now let's not conflate the two worlds. Inside this world, everything is automated. We said environments can be created and destroyed at will, so we're not supposed to hold really state in there that can't be reconstituted. And releases can be performed at will. Typically, this results in every 2 weeks, but sometimes it's faster or longer depending on business needs. But the goal was there should be no barrier. We can do it whenever we need to. So the second part was establishing a set of rules for this environment. And these rules and these assertions were very important in order to kind of maintain the integrity and the architecture of this process. So first thing we did is we defined this purpose-built, fully automated image that was constructed automatically, kind of like a spring-loaded system that had all the agents, everything you need to have a service up and running inside of it. And said, these are our established patterns. Everyone coming on board with this has to adhere to one of the established patterns. And if you need a new pattern, great, we can make a new pattern if we need to, but we need to get rid of that deviance in configuration that didn't need to be there. The other point is this image, which we call the AIT, is designed to be immutable after first boot. So if you need to change an agent, a patch level, anything, you're supposed to redeploy through the pipeline, create a new image, not edit it in place. The testing process through this needs to be completely automated without any manual tests. Any supported tooling in here has to support full configuration via API. Also, the tooling needs to be able to support the dynamic nature of the environment. No manual steps are allowed during the release process. In order to maintain the integrity of the environment, we said for operations and for administration, you have to rely on all of our external tooling, so Elk, Rundeck, Prometheus, to be able to do diagnostics and operations. You're not allowed to log into that system. We put a compensating control in place because sometimes you do have to do that even when you have all these things in place. So we have a little job that kind of unlocks the system. It generates a random password for it, gives it to a user, and then basically flags that system to be rebuilt in 24 hours back to the norm so that we have a consistent configuration through the farm, and we have that compensating control to make sure any deviations are gotten rid of. And finally, any persistent change to the system must be pushed through the delivery pipeline. So that's our system of record for what the environment's supposed to look like. The second part we had to do was take a look at how we managed our environments and start defining them through code. So we had this loose concept of what an environment was. It was an assembly of systems, and different teams had different environments. We needed a way to formally define it and figure out how systems get configured inside of it. So we started out and said we want to derive everything from Git. Everything goes through source control. If you want to alter something, you make a pull request into that repository, and that's our system of record. That gives us kind of implicit change tracking auditing. We always know who changed what, when they did it, why they did it, as long as they put a good note in the commit. And pull requests give us an approval process and visibility to changes. Everything also can be reconstituted from source code if needed. And what we did to be able to propagate these changes out is we used Consul, which is really a really nifty tool. We basically use a utility called Git to Consul that grabs the data out of our environment manifest Git repository, pushes it into Consul in a defined structure, and then all these other different systems have a process called Consul template that's running. Just basically queries Consul data and renders files on the system that other things can look at. And its job is just always keep it up to date with the data in Consul. So we define this environment manifest. We say, here are our environments. They're defined through code. They're defined in configuration. And everything's going to make its decisions off of that. Then we said we're going to build our pipeline. And the purpose of this pipeline is really a general purpose pipeline. Everything pushes through this. So not just code, although software releases are the primary motivator here. Because we are doing blue-green and because we are creating all our systems on demand, we can really push any change through this pipeline. So this includes things like system and security patches. If you want to test an application and see whether an update to Java or a .NET framework or even a security patch will affect anything, you push it through the application's pipeline, it picks up all that functional testing, and you'll have confidence at the end of the day that whether it broke things or not. Same thing with operating system updates or upgrades, changes to agents or system configuration, software releases, all of it flows through the pipeline, all of it's derived from version control. At the end of the day, this gives us a system where anyone's confident you can push a change through and have it be tested, rather than kind of having one person who patches the system and another person who validates the application. So if we take a look at our pipelines, if anyone who's familiar with Jenkins, this is Blue Ocean view. An example of a pipeline that worked and a pipeline that stopped early on in the process. Basically, we dynamically generate based on that environment manifest the environments to be able to deploy to in the order that they're deployed to. So when you click build, the pipeline is actually idempotent. So what it'll do is say, if you click build and there's no change, it will check all the environments in order and say, all right, you have version 5 of this software. Check all these environments to see if it matches version 5. If not, deploy to just those environments that are missing this version. So it can pick up and resume wherever it left off. That wound up being an important part because if something fails near the end, and for an ephemeral reason like a network blip or something along those lines, you don't have to restart the whole thing from scratch. So what does our pipeline look like? Well, on the outside, we have that automated image template that I spoke about. That's that we call the AIT. We build that with Ansible, and it's continuously rebuilt at the latest patch level on a regular basis. So just on a schedule, constantly takes the latest patches. The contract with the application teams is they will always, every single time you run the pipeline, take that latest version of that image. And since all patches and everything are tests, you're expected to address any issues with any issues that would come up as part of that process as part of that software release. That's the contract, is everyone always takes the latest. This includes all the software monitoring agents, everything in there with a blank configuration. We basically kind of spring load that image with a console template and basically say when this is provisioned in this environment, it gets what environment it's in, where it is, pulls in all its configuration, wires up all the agents, everything that needs to go, and then it's all set. And this is tested also independently of the application. So all those agents that I spoke of have their own tests to make sure that their files are rendered appropriately and they do what we expect them to do. Finally, the first phase is the build test phase. So Jenkins is what we use here, and we use specifically the Jenkins pipeline functionality, so we don't use the legacy freestyle jobs. It's what begins the orchestration process. The software is built, unit tested, et cetera. The deployment strategy is defined in a YAML document inside of the application, so that defines whether it's going to do a blue-green or a Canary deployment. So then we go to the deployment phase. This is where we render a heat template to basically encapsulate that new version, all of the infrastructure, everything that it needs, and the Avi load balancer pool that will basically define the load balancing strategy, whether it needs persistence, all those fun things. So we will deploy that heat template, and then we will sit there and we will just wait for it to come back up. It'll self-configure. We got a polling process outside that just kind of sits there, and I'll show on this slide. Basically a polling process that goes out there and basically sits there and says, all right, are you ready yet? Did you construct? Did everything go all right? Are all your monitoring agents all set up? So what we did is we have a Python library that we built that orchestrates this deployment from a high level. I'll explain that a little bit in further slides. It creates a heat template, and it just sits there, waits for everything to come up through this little agent that we've included. And once everything's happy, reporting like it's ready to go, no issues constructing, it moves on to the next phase. The initial part, so the Actual construction is handled by a nifty pattern called the Autopilot Pattern. So what this pattern basically states is, rather than centralizing all this deployment logic and all this special stuff you'll have to do for each application, put it in local scripts on your system in these standardized lifecycle events, and your deployment process just calls those. So if you have to do anything special for an application, like pre-warming it or a special kind of health check, those are included in local scripts in the application. And the contract outside to everything else are these standard lifecycle events of like start, stop, in service, out of service. And that makes it very easy to do things like auto scaling and have kind of hands-off provisioning of systems. So next we'll go into the validation phase. And what we do is we take all the systems of that pool that we had before, we hook it up to the load balancer, expose it on a separate port, and run all of our functional smoke tests against it. So now it's in the environment that it's going to be deployed in. So this is a production environment, it is in that production environment. And we are testing it in that production environment with the smoke and validation test before it actually takes any customer traffic. This is a very important benefit to the blue-green process because you can validate the entire thing atomically right before you route a single request to it. That's something fairly unique to blue-green. So if we take a look at what this actually looks like, we will have a pool group in Avi and for our test traffic, and we'll have a pool group for the live traffic. And while it's being validated, it's put into this test pool group, and that's what wires up that special port and brings in all the test traffic. And we'll have the live traffic sitting in our active pool group. That's where all the customer traffic is going. So if any part of this fails, this is the nice part about blue-green, is if any part of this fails, your recovery workflow is very simple. You haven't affected any customers yet. You just archive the system or delete it, do whatever you need to, but you don't need to worry about recovery or really rollback at this point. It's all handled by switching traffic at the load balancer. So your recovery actions are really clean. You don't get into any of these really complicated to recover from scenarios because your failure state's really binary in this case. So whenever anything's affected, usually we catch it before any customer notices at all or serves a single request. It also prevents a lot of the it's working in my environment problem because we get to validate the entire thing before any customers touch it. So if somebody's opted into a Canary deployment, and most of our deployments do these days, basically we enter a phase where customer traffic now begins to route to this new pool. And basically the error rate and the customer experience are monitored during this process. And it will gradually increment over time until somebody either aborts it or it succeeds. So if we want to take a look at what this looks like, here we have a output to our chat application, which kind of shows what this is flow doc if anyone's interested, what a deployment actually looks like in the Canary mode. So here we've got an example. The automation factory is saying, all right, we're going in our live environment, and now we're routing 10% of customer traffic in this environment over. It says who's doing the deployment, who's incrementing it, and then we upped to 50% traffic, and then we went over to 95% traffic and finally released. So one of the nifty things on there is if you see it actually tags it tags the version, the software, everything in there. You can actually click on those tags and it opens up a little thread where anyone can discuss the release issues that they're seeing just live in that chat, which is pretty nifty. So finally, if everything passes, we go over to the promotion phase. So this is where we're shifting 100% of the traffic over and we're considering this released. So now the old version is retained for a period of time, however long you need to be able to have confidence that this release has actually succeeded and you won't need to roll back. While that's available, if anything goes wrong, you need to roll back. It's just a load balancer setting. You just go through, shift the traffic back to where it was, and you're all set. So keeping that around for a while gives you a good bit of risk mitigation. It also lets us push changes out to live very quickly and confidently that if anything goes wrong, we can just push all the traffic back to the old farm of servers and investigate it later. It's a very valuable thing to have. So this is an example of what it looks like once we release. You'll see basically that pool group is moved over. Now it's in a lower priority than the older version. And the newer version has now been released and it's taking live traffic. So the orchestration of this deployment. Basically what we did here is we experimented with a lot of different strategies, a lot of different configuration management tools, and we found the best strategy for us for this orchestration was basically to build a lightweight Python library to handle the orchestration. We found that easier than working with pre-built tools, but the important part to that was to offload the responsibilities to open source tools whenever you can. So this library doesn't do everything, it just orchestrates. It'll offload to Ansible, OpenStack, Heat, a lot of other frameworks for various responsibilities. It's just orchestrating this process. It makes it easy to implement resiliency patterns, retries, all sorts of other things. It also makes it really easy to test. One of the important things that we found is testing our deployment process is very important. So we have a set of unit and integration tests that we can run to make sure our deployment process and our Canary process is non-disruptive and functional and it routes traffic however we want to, and that it's correct. That was something very important to us and made it very easy to do when we had this orchestration layer in Python. Another important part is you need a clear definition of the roles and responsibilities of tooling. Tooling in the space, a lot of things can do almost anything, but they only do a certain set of things well, so you need to define that. And to prevent getting a tool, trying to have one tool do everything and having it do a small set of things pretty poorly. So lessons learned. We learned a lot of lessons going about this. One of the big things is you need to, when you start out, be prepared to make sure all of your supporting tooling can be automated and can scale the way it needs to. A lot of our tooling, either some of it didn't have APIs or the APIs weren't functional enough or it couldn't scale to the dynamic nature of blue-green. Because sometimes you're going to have a lot of systems coming, a lot of systems going, and sometimes adding or removing that many systems from, say, a monitoring system can cause problems. Testing is extremely important. You want to validate everything at every stage of the pipeline. So each system we have self-validates, make sure that monitoring is correctly hooked up every time a new system comes up, that all of the supporting tooling is in a correct place. It's constantly validating that. And that has paid off many times for us. Don't underestimate the amount of cultural change required here. You're changing the way people have been operating for a while. You're now changing it to a completely hands-off and automated system. And a lot of people get attached to their tools, to actually having a name for a system. You know, you'll say this is Web Server 40, and Web Server 40 is acting up today, or it's always been weird, and then you've got the system over here that was built at the dawn of time that doesn't look like the new ones. But people get attached to that identity. In this mode, systems get a unique identifier or get the IP address as the name or something along those lines, and you have to query other systems for their identity, and that's a cultural shift you have to be prepared to make. You won't start this transformation until you're actually in production. You can begin to figure it out, but once you're really only at the starting line once you have your first app actually in production. And that's when you start to realize the value that you have this infrastructure that can be created and destroyed at will in a very easy, low-risk release process. Don't start off trying to automate a manual process. That usually results in a very hard-to-automate process and a very fragile process. Instead, just figure out what the process is that you want, what's the ideal automated process, and try to build from there. And change your processes and tooling as needed to support automation. Buy-in from all levels of the organization is critical. You really need support from all the stakeholders, and you cannot solve this problem in a silo. And the last one, which is kind of funny, we talk about blue-green because it's the name for this type of deployment, but it's very ambiguous. You'll get a lot of arguments over what is blue and what is green, and when you've released, does green become blue? And somebody invented a term called brown when a pool doesn't come up. There's a lot of ambiguity. You'll probably start talking about this in terms of current or next. Reduce it down to less ambiguous terms because blue-green will get pretty ambiguous pretty quickly. And I think with that, I am all set. So does anyone have any questions? Oh, yes.
Hello? Yeah,
Yep.
I've got a question about the blue and the green, which is the new version, right? You said when the green version doesn't pass the validation that you switch the load balancer, switch back. And for example, when the new version, which is the green version, has corrupted the database, so some data has been corrupted, how can you do the rollback?
Yeah, so that is a complicated problem. So when you're dealing with state, blue-green is really easy when you're talking about stateless applications. When you're talking about state, you really have to think about your processes in dealing with databases and say, so for example, one of the things that we try to do in dealing with our release processes databases is make sure as you increment through your process that each change you make to the database is backwards compatible with the last. Sometimes that means you need to do a little bit of orchestration, like do one release out that can support both versions and make sure everything is all right, and then apply apply a schema change or apply a larger, your persistent change, and then apply another software change on top of that, which is easy if you have a quick pipeline, but it does require you to actually kind of think about how am I safely going to deliver this persistent change. In terms of corruption, you kind of have to go back to a backup. There's nothing blue-green can do to help you there. But you're right. This is very easy pattern for stateless applications. Stateful requires some thought.
Thanks.
Yeah, typically for continuous delivery applications, the model is that the state you do move to the next version separately from all your application layer, like all your microservices or all your applications that are using your DB. You move the DB to whatever newer version that can support both, like old API calls and the new API calls to the DB, and then use the blue-green for all your applications, microservices.
Thanks.
All right, well, thank you very much.
Yes.